All right, let's proceed to discuss the hardware setup and connection for non-invasive blood pressure monitoring. Firstly, it includes our heated temperature controlled chamber, as well as our signal acquisition system and our main unit process, the signal acquisition system. Then there is an output here, our 2 units, signal channel 1 and channel 2. Channel 1 is connected to one of our pressure channels. Channel 2 is connected to our pulse sensor channel. Additionally, there is an external trigger here, as well as an air pressure port. The external trigger refers to our trigger handle, which can be used to perform experimental operation. And this air pressure port is connected to one of our pressure gauges. Inside the chamber, we have a tail cuff here, and the rat sail will be passed back through the tail cuff and then detected by this pulse sensor for the fluctuation of an arterial vessel in the rat's tail. Operating this display screen. The upper left corner shows the real-time temperature inside the chamber, followed by our set temperature, the target temperature we've had set, and this is the real-time pressure within our chamber S pipeline. This is a target we've set, the exhaust pressure, and here's our holding time, which is the time it maintains after reaching this target pressure. It maintains this horizontally for a certain duration, and then there's a cycle time. It cycles this. Well, the number of cycles is one of us. We divide it into multiple cycles and single cycle. Single cycle is the same as using our external trigger handle. And the multiple cycles below the single cycle is a cycle for us. It cycles here 10 times with a 10-second interval. Hold for 4 seconds. After exhausting the air, ensure it's up below 10 millimeters of mercury. It has a 10-second interval before proceeding to the next cycle. This is how we operate our interface. So once we're ready, we can place the rat into the temperature-controlled chamber for heating. A piece of paper can be placed under the rat after placing it inside. The temperature inside the chamber can reach our target rate, that target temperature. Once the target temperature is reached, we place the rat inside under normal circumstances. Mice are left for 12 minutes, and rats for 10 minutes to allow them to heat up. All right, let's discuss the use of this non-invasive blood pressure software. First, we open MedLabs, the English version of the software. When opening the software, we need to ensure that our system is powered on. Then connect the data cable at the back of the system to our host. Using a USB printing cable, after confirmation, we double-click to launch the software. Once open, this is our initial interface. Then within the initial interface, first we need to set the number of channels. Then click on Set Up. Then adjust the number of channels accordingly. Confirm. Then for the upper frequency of the 2 channel, set it to 10 Hertz. For channel 1, etc. We click on this. And then click on Setting for the process name. We need to set it to blood pressure. Well, the others are all checked. No need to adjust. After making the adjustments, we then need to set the unit for blood pressure. Then click on the plus and minus icons in the bottom right corner. The plus icon is for enlarging the unit. The minus icon is for reducing the unit. So the one above is for centering the curve. Then we select the zoom option. Zoom in to set it to 50 how much per division, since normally we inflate to over 200. Then maintain it in the exhaust phase. This makes it easier to see. Next, adjust the second channel. Click on the name settings. Select from the name dropdown. Locate our first pulse. No need to change anything else. Then click OK. The unit for pulse is millivolt, and we proceed as normal, depending on the size of the animal you were measuring for normal mice. We click on the plus sign for mice. We initially set it to 1. For rats, we initially set it to 2. Then check its waveform. Or you can set all to 2 as well once this is set. We can proceed with the measurement. But if we don't want to set it up like this every time, we can click on the file drop-down. There's an option called Save Configuration. Let's add input and save the configuration. Enter our name. For example, 123,456. This represents our single channel configuration file for non-invasive blood pressure. We click Save. Okay, if we turn on the computer next time and find that we are returned to the default settings, and we don't want to set it up step by step, we can click on the file drop-down and find the option to open the configuration. Then open the 123,456 we saved early. It will load the parameters we had set before and apply them all so we can use them directly. All right, next we will secure the mouse. The heating duration for this mouse is sufficient. Firstly, when securing the mouse, we need to ensure its posture is correct. We need to locate the central artery directly beneath the abdomen of the mouse tail. Let's take a look. If we place it like this, the mouse posture has already changed. It's set in this position, which is a lying down position for it. So we need to position the fixation tube like this. And the first step is we need to guide the mouse tilt through the tail cuff. After the tail passes through the cuff, we then position the pulse sensor at such detection end facing upward with the detection end facing up. It should be placed directly under the abdomen of the mouse set's tail. Then you can align the mouse sail with the sensor and pinch them together with the wire. Using the fingers of your other hand, gently secure this. You can tie it to secure it, but avoid tying it too loosely and not too tightly, just enough to prevent it from sliding. If we check it now, it might be a bit loose, so we will untie it. We'll pull on it from above. It should not slide. That's sufficient. After completing the operation, cover it with this insulating material, the lid of the warming chamber. All right, let's say I click to start the data collection. You can see that the second channel corresponds to the pulse status of this mouse, normally after preheating for 10 minutes. The amplitude of the signal is approximately 10. And as the mouse mood stabilizes, along with continuous heating, the oscillation occurs, and the pulse signal will gradually increase in amplitude. We can wait patiently for a short while, in about 1 to 2 minutes, in about a minute or two. We can proceed with the measurement. Currently observing the pulse condition. It is persistent. It's progressing in a favorable direction. Then it continues in a state of diastole. We can wait for a moment. Before we proceed with the measurements, a value of the pulse. We focus solely on its amplitude. We don't need to concern ourselves with the specific number. However, the blood pressure in this channel is a setting we intend to measure. Therefore, before the measurement, the pressure inside our tube is 0. Before the test, we need to select this blood pressure option. Then click to set the limit to 0, allowing it to return to 0. We currently observe it as a negative value. Click to reset to 0. This will reset his blood pressure value to 0. And what we see now is this one. The pulse signal remains relatively stable. We can then proceed to pressurize. First, click for a single instant. Let's take a look. This blood pressure reading is too low. Then we can calibrate it. Then we can adjust this whole time. Set it to 20 seconds. Good. Then we click pressurization once more. If we can observe this blood pressure value, it's not at the value we set. We can then click on this blood pressure and click on the transducer calibration. Then input this new value as the real-time display on our pressure gauge. Our pressure gauge shows 195 mm. then enter the new value, click OK. All right, then we click to zoom in. Next, we will adjust this. Hold time back to 4 seconds. All right, let's proceed with the pressurized measurement next. Once the pressurization pressure surpasses the systolic pressure value, we can observe a change in its behavior. The arterial pulse signal gradually fades away and then stabilizes. These are the interference signal, followed by gradual deflation. During the deflation phase, the first peak emerges and then slowly transitions to diastole. This is the entire measurement process. We can then proceed to click multiple times. Once the pressure drops below 10 millimeters of mercury, our programmed interval is set to 10 seconds before proceeding to the next measurement. This is the process of pressurization, stabilization, and exhaustion, followed by a normal pulse signal, which then disappears, and then gradually reappears. It appears and then gradually returns to normal. All right, due to time constraint, we will collect data up to this point. Next, we will move on to the data analysis phase. Firstly, we can see in the lower right corner that there's a sampling frequency. When we are normally collecting signal, we set the sampling frequency to 20.1. Then we can gradually proceed in the data analysis stage and make adjustments accordingly. For instance, if we want to analyze the waveform of this test data, we select what we need. In fact, what we need is during the exhaust phase, from systolic pressure to gradually diastolic pressure, such a waveform condition. We are interested in the pulse signal from this section. Other signals may interfere. Well, we can disregard other situations as long as the data signal is stable, we can utilize it. We first drag the desired signal to a portion of the entire screen, about 1.6 or 1.7. Next, click on the stretch icon, then adjust the sampling ratio. 5.1, that's on the ratio. With this, we can observe the overall signal status. We can observe that this is where his pressure has surpassed the pressure, where the pulse signal disappears. And then as our exhaust phase emerges, we can see when it reaches the systolic pressure during the exhaust, our first stable pulse signal appears. Then the ones before. These are all interferences. We can refer to this as the timeline. This is the timeline. Sometimes when we were collecting and analyzing data, if you double-click on this timeline, you'll notice that the scroll bar below disappears, and then double-clicking again brings it back. Another point is when analyzing, if we were only analyzing the second channel, we can place the cursor between the first and second channel, and it turns into an up and down arrow. A single click allows us to zoom in on the second channel. Then by scrolling the wheel, the mouse wheel can adjust the position of this curve. And you can also zoom in on this curve and then stretch it. This helps us better observe the pulse signal and thus observe its blood pressure. Then we can see it becomes steady at a point in the signal right here. Then as the pressure gradually decreases, our pulse signal gradually amplifies. Gradually amplifying, we can see it amplifying to the point at the secondary peak. And then there's a clear step back. That is after the point where our systolic pressure appears. It gradually relaxes, and after reaching diastolic pressure, a peak occurs. And then there's subsequent step back, followed by a reduction. So we are on the timeline starting from the systolic pressure point, pull back to the diastolic pressure point, and stop there. Then this area will display systolic pressure, diastolic pressure, then the pulse pressure difference and mean pressure. If we pull and the values do not appear, it might be because a shortcut menu on our software has an online measurement option that wasn't clicked. Let me show you. If we click on this online measurement option, no matter how much we pull, data 1T appear in the upper right corner. We should click on this online measurement option and pull again. Then the desired data will appear on the right once this data is confirmed. It's sent what we want. Then we click on the icon in the shortcut menu bar above. There's send option for processing results into the data window. It set the table. And then the M symbol with a horizontal bar. We click on it and it turns gray. Turning gray indicates that the results of our processing have been saved into our data window. Let's say I process it again. Let's Snsek continue to pull forward. You can click this black triangle to drag forward. Alternatively, you can click on this blank scroll bar and it will move one screen forward. Or you can click on the black triangles on both sides of the two levels for a slower move. All right, let's return to the previous measurement cycle. Then we can continue with our previous operation. Click on the systolic pressure position, the point where the wave crest appeared. Then pull back to increase to the maximum point. Then the peak just before the point where it starts to recede. Stop. Then click on process result to enter the data window. We've processed it twice just now. Let's do one more time. Good. Well, at this point, we can take a look. Sometimes it appears as a peak, but since the baseline of this waveform isn't on the same horizontal line, we can determine the difference between its peak and trough, or the peak of this wave. The difference between the peaks and troughs is the greatest, which means that at this point, the blood vessel is in a diastolic state. Then proceed with processing the result and enter the data window. All right, the 3 data sets we just processed it. And then we click into the data window. This icon resembling a table represents the data set. Click on it. We scroll the wheel. This is the data for channel 2. Then we proceed to channel. In channel 1, we can see the timeline we were just looking at, from 268 to 269 seconds. And also from 247 to 248. While these 3 time periods, we've pulled the process result data, the average of his 3 data set, and the standard deviation. All the systolic and diastolic pressures are here, which is the data result we ultimately want. Once we've processed this data result for one hand, if you wish to save this data, you can click on the top left corner where there's send a file menu. After clicking on the file menu, you'll see an icon resembling a piece of paper. It will prompt you to save. Click yes. Then we can enter a name. Save to the desktop. All right, once we've aerated a new file, we can proceed to process the next set of data. So we can return to the data window to review it. At this point, the data window is now empty. This means that we have saved the data from our previous analysis and then cleared the data window. Upon returning to the data window, we see a red wavy line at the top and a blue wavy line at the bottom, which represents our initial interface. It's also our sampling window. Go back into the sampling window. We can then return to the desktop to check out the tabular data we just saved. Upon double clicking to open, we can. This is the data from the mouse we just brought. We have saved it, and you can name this. This is the raw data for this mouse. Then we return to the software. when this is the first data set. It is called. Blood pressure data is also our most crucial data. Another measurement we can take is heart rate. We typically measure heart rate during a measurement. In the mid to late phase of a mouse measurement cycle, waiting for its mood to stabilize. Once the state is stable, we can take a segment, a long and stable pulse waveform. At this point, we can adjust this and observe parameter. From online measurement to segment measurement, after clicking to calculate the measurement, so we can see the number of channels in the upper right corner. Then we adjust the number of channels to 12, the last parameter, is our heart rate. At this point, we no longer need to drag on the timeline, because dragging on the timeline covers channels 1 and 2 through channel 2. The pulse signal condition to determine its blood pressure. Then at this point, we only need to extract a segment, extract a stable pulse waveform from the second channel. It will calculate it for us. A heart rate setting is applied. Then we click this to add it to the table TC. Okay, it turns gray. Then we return to the data window to check. In this data window, the measurement section will display the data we just processed. This is one of our heart rate settings. Similarly, you can click this to save. You can also go and adjust this. Since there's only one data point, you can also record it individually. Then we return to the sampling window. There's another thing we need to discuss, which is during the collection process, we will also use a marking feature. There are two types of marks. One is the conventional marking method, where we enter what we want in this mark window. For example, the one we desire, marking symbol. 123, and then first we click this to meet the standard. Then click on the location first. Then click on one of ours to meet the criteria. And if we say this mark, we don't need it, click to clear. First click on one of ours and enter our marking content. Then enter the marking position. Then click the plus sign to mark and hit this position. Under normal circumstances, we can have a simpler method. That is to say, if you keep counting it, we can click on this. Just stopped. Then you can start on click. After we have collected a piece of data, this is when we proceed to collect data from the next rack. We can click this to stop. Then click start. At this time, we can see that it has one dividing line. This dividing line, this marks the boundary between our two mice by using this method. We can also isolate the two mice. You just need to keep track of the measurement sequence for your mouse after we just click to save. The data was not saved. Let me explain to you if we accidentally fail to save the data and we still want to retrieve it. How do we find it? We click on the file drop-down, where there is an option called Recycle Temporary Experimental Data. Then we click on Recycle. It will display one of ours. The time when we conducted an experiment, the corresponding time, which time period we conducted an experiment and made data after you find this data. For example, if we just made this data around 9 o'clock, then we click on Recycle. Recycle, then we click on a save path and enter our name. Then click OK. Alright, at this point we can click on File to open. We want to save it this time. Open the file we just recycled. Click to open. And you can see the data we measured before. And it's this is a feature of our software. Better aspects. That is to say, as long as the software you've made the data, then we will have a certain record. We can go and retrieve it, meaning there is no situation of data law. And there's another point we want to discuss, is the saving of a curve. That is, if we need to insert this image in the form of a picture into our article to more intuitively reflect the process of our experiment, then we can capture a segment of the experimental curve on the timeline. Click on the experimental curve to access the print editing window. After clicking, well, just before the processing results appear in the data window, it won't turn gray, but we have already saved this data, saved in the print preview window, right in between the data window and the sampling window. We open it. This is the format of the image we just saved. This is akin to an experimental report. Then we can double click on our parameters. The top section contains our experimental information, and on the right is the corresponding experimental data. Of course, this data is not the actual data we intend to measure. You can then double click on it and input the data we may actually measure. Fill it with the real experimental data. Then you can click on this to print. We can pop up a PDF window, for instance, if I save it, then save it to the desktop. Or we can see that there is now one on the desktop. A PDF file lets us double click to open it. And this PDF file is the one we just saved, in a style similar to an experimental report. You can adjust within this software. A satisfactory condition is needed. Then export it. Or after you've made your adjustment, use third-party software to take a screenshot, then proceed to optimize. Or adjust according to the teacher's actual requirement. Then we return to the material factory. Well, this is another feature we need to discuss. It's our data window, an observation feature of the data window. In addition to what I just mentioned, placing the mouse between channels, you can move up and down to display the maximum channel situation. You can also double click. For instance, if I double click on channel 2, it will then fully display channel 2. After that, if we double click on channel 2 again, it will bring up channel 1. And then both channels will be displayed. This is how you use our software.